Welcome to the Pocket Science channel. We have already covered most of the basics and some other types in integration. If you haven't watched it, please watch it from the link given below in the description. Today I am going to do a new topic under integration. That is integration by parts. We know already when a function is expressed as a product of two functions, we can derive it by this way. Here I have taken u and v as the two functions. Now I am going to differentiate this uv with respect to x. Then here you know already how to derive when it is given as a product of two functions. First function u times the derivative of v, dv upon dx, plus the second function v times the derivative of u, du upon dx. Now I am going to make this part as the subject in here. And it will be u times dv upon dx going to be equal to duv upon dx minus v du upon dx. Now I am going to integrate both the sides with respect to x. Integral u dv upon dx times dx is equals to integral duv upon dx minus v du upon dx times dx. Then in here I can express this one as integral u times dv. I can simplify this dx part. Then similarly here I can take this separately as integral duv upon dx times dx minus integral v du upon dx times dx. Then if I simplify in here, I am obtaining integral of 1 with respect to uv, integral 1 duv minus integral v du. Now you know you can express this part as uv. Here the integral of 1 with respect to some unknown term, it's going to be that term, it is uv in here, uv minus integral v du. Then we can come to a formula, integral u dv is equals to uv minus integral v du. In here u and dv upon dx are two functions of x. Therefore we can say u dv upon dx is a product of two functions. Then this formula can be used to integrate a product of two functions. This is known as the formula of integration by parts. I will explain it further by using some examples. Here the first example I am taking integral x ex dx. Now you can see a product of x and ex in here. The one we are selecting as u should be able to easily differentiate, and the other one should be able to easily integrate, like this. When I take here, let u equal x, then I can differentiate this one with respect to x, then du upon dx will be equal to 1. Then from this I can write du equals to dx. Then the remaining is integral ex dx is the remaining part out of this. Then I can take integral dv as equal to integral ex dx. Then if I integrate this one, I am having v equals ex. Now according to the formula, you know the formula is integral u dv will be equals to uv minus integral v du. Now I have made this integral x ex dx to the form integral u dv. X is u and the remaining part is dv. Then I can write integral x ex dx equals to uv minus integral v du. In here u is x, v is equals to ex minus integral v is equal to ex, du will be equals to dx. Now it is easy to get the final answer from here. Ax ex minus the value of this part, integral ex dx. The integral value of ex is also equal to ex plus c, where c is an arbitrary function. This is the final answer. I am taking another example. Here is the second one. Integral x squared ex dx. Now, in the similar way, I am going to take u as x squared. Let u equal x squared. Then let's differentiate this one. Then we are having du upon dx equals 2x. From this we can write du equal 2x dx. Now what is remaining? Integral ex dx remaining. Then we can write integral dv as integral ex dx. Then I can say here, if I integrate this one, v is equals to ex. Now I am directly applying the formula. Integral x squared ex dx will be equal to uv minus integral v du. U, here u is x squared ex minus integral v du, v is ex times du is 2x dx. It is 2x dx. Now here the next step, x squared ex minus 2 is a constant, I can take it out. Then I am having integral x ex dx. Then in here again I want to use the formula of integration by parts in here. since I can't use any other methods to integrate this one. See, this is similar to the previous question. Therefore, I am using the final answer in the previous question. But when you are writing the answer for this question, you have to write all the steps which I have written in this previous question also. See, I am using this final answer. The integral of x dx is equal to x ex minus ex without this constant part. Okay. And here it is equal to x squared ex minus 2 times. I am using this one. X ex minus ex plus c out. Okay. Then here the answer is x squared ex minus 2 times x ex, then 2x ex plus 2 ex plus c, where c is an arbitrary constant. Now let's move for some more examples very quickly. The next one I am using integral ex sin x dx. Always keep in mind, when there is an exponential function, always leave it for the v part. Then at once you can take u as sin x in here. Then let u equal sin x. Then you can write du upon dx equals to cos x. Then you can say du equal cos x times dx. Then the remaining integral dv is equals to integral ex dx. Then by integrating we can take v equal ex. Then integral of ex sin x dx. I have found all the terms u, v and d. Then u times v is going to be sin x times ex minus integral v du. V in here is ex times du is cos x dx. Look here. Here ex cos x dx. Then again I want to use the integration by parts method in here. Therefore I am taking this one separately as equals to some unknown term as capital I. Then after finding the integral of capital I can substitute it in the previous question. Now let's see. I equal integral ex cos x dx. Okay. Then similarly now I am going to take u as this part cos x. Then du upon dx will be minus sin x. Then I can write du equals to minus sin x dx. Then the remaining integral dv will be equals to integral ex dx and v equals ex. Now I can write I equals uv minus integral v du. U is cos x times v ex minus integral v du. V is ex times du is minus sin x dx. Then if I simplify this one, I am having cos x ex minus times minus plus integral ex sin x dx. See, ex sin x dx. This is same as the question what we are having. It's okay. Now I'm going to substitute this and look what is going to happen in there. Then say the question is integral ex sin x dx equal, we have already found that it's equal to sin x ex minus I, then sin x ex minus the I, we have found the integral of I as cos x ex, writing inside bracket, plus integral ex sin x dx. Okay, now if I remove the bracket by multiplying with the negative sign, I am having minus cos x ex minus integral ex sin x dx. Then if I take this minus ex sin x dx to the left side, I am having 2 times integral ex sin x dx. Okay, at once I have written that step, equals to sin x ex minus cos x ex. Then now I can write the final answer of integral ex sin x dx will be, if these 2 get divided, this whole formula sin x ex minus cos x ex, we are having half times, I can take ex out and I can write sin x minus cos x plus c. There c is an arbitrary constant. The next example is integral of tan inverse x dx. Here you can see only one function. It is the inverse function of tan ratio. But for this, there is no any other method of integration. We can only use the method of integration by parts in here. See, I am considering this tan inverse x as the u in here. U equals tan inverse x. Then if I differentiate this one with respect to x, du upon dx will be 1 upon 1 plus x square. Then du is equals to 1 upon 1 plus x square dx. And what is remaining in here? You can see the remaining one is only the integral sign and the dx. It's okay, you can take integral dv as equals to integral dx. Then you can get easily v equals x. Now by using the formula, I can write integral of tan inverse x dx will be uv minus integral v du. U in here is tan inverse x times v is x. Then tan inverse x times x minus integral v du. V is x times du is 1 upon 1 plus x squared dx. Here then it's equal to x tan inverse x minus, here at the denominator we are having 1 plus x squared. Then the derivative of the denominator in here is 2x. You can make 2x in the numerator easily because already there is a x in here. Then if I write 2x in the numerator, 1 plus x squared remaining in the denominator, to remove this 2, I am going to divide it by 2. Then I can write half times 2. Okay. Now here x tan inverse x, half is a constant, then I can take it out. Now you are having integral 2x upon 1 plus x squared dx. The derivative of the denominator is at the numerator. Then we can directly write this as ln 1 plus x square plus c. Okay, no? Due to the lack of time problem, I have discussed only a few example questions under the integration by parts in here. For more examples, please keep our channel subscribed. Thank you.